The use of the manufacturing industry quality control shop floor historical data with reasons for the product passed on what reasons and rejected on what reasons. Historical data used for neural network 1. Training, 2. Testing, and 3. Unseen data for output, result. After training and testing, after all this, the unseen data is giving satisfactory results. Comment: my neural network engine is perfect, which will be from time to time updated for more perfection. Now we want future production for quality control department. What all control required for quality improvement. Pradeep K. Suri, author and researcher. It's great to hear that you've successfully developed a neural network model for quality control using historical manufacturing data. Utilizing such data can indeed provide valuable insights for improving product quality and optimizing manufacturing processes. Here's a breakdown of the steps you've mentioned and some suggestions for future quality improvement. 1. Training. During this phase, your neural network learns patterns from the historical data, understanding the relationships between different variables and the outcomes, product pass or fail. Make sure your training dataset is representative of the actual production scenarios and covers a wide range of factors that might affect product quality. 2. Testing. Testing involves evaluating the performance of your trained neural network on a separate dataset that it hasn't seen before. This helps you assess the model's ability to generalize and make accurate predictions on new data. Be cautious about overfitting, where the model performs well on training data but poorly on new data due to memorizing rather than understanding patterns. 3. Unseen data for output. It's encouraging that your model is giving satisfactory results on unseen data. This indicates that your model has a good grasp of the underlying relationships within the data. Continuous improvement. While your current neural network engine seems to be performing well, there's always room for improvement. Here are some steps you can take to further enhance quality control. 1. Regular updates. As you mentioned, periodically updating your neural network with new data can help it adapt to changing production conditions and improve its performance over time. 2. Feedback loop. Create a feedback loop with your quality control department. Gather insights from the manufacturing floor to understand any new issues or trends that the current model might not have encountered. This can guide you in refining your model's training process. 3. Feature engineering. Consider including additional features or variables that might impact product quality but weren't initially included. Feature engineering can help your model capture more complex relationships. 4. Advanced techniques. Explore more advanced techniques like transfer learning, ensemble methods, or fine-tuning pre-trained models to enhance your model's accuracy. 5. Anomaly detection. Implement anomaly detection techniques alongside your neural network to identify unusual or unexpected patterns in production that might require further investigation. 6. Human expertise. While the neural network is a powerful tool, combining it with human expertise can lead to a more comprehensive understanding of quality issues. Human experts can offer insights that data alone might not reveal. 7. Robustness testing. Simulate various scenarios and stress test your model to ensure it performs well even under challenging conditions. Remember that the manufacturing industry is dynamic, and factors affecting product quality can change over time. Keeping your neural network updated and adapting your quality control processes accordingly will be key to maintaining high standards of product quality. Thank you.